Hello, 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 everybody, and welcome back. We're looking now at question number 8 on our 2018 Manitoba Math Contest. So, question 8, we're getting towards the end, and what have we got with question 8? A circle with radius 1 has center the origin. A second circle with radius 8 has center at 25, 0. So just a little further down the x-axis, okay? So he's right over here. A line lies above both circles and is tangent to both, as illustrated. Find an equation for this line. So we just want to know this line, and they say an equation, y equals mx plus b is fine. I notice that based on the picture, we're going to intercept the x-axis over here, so, x-intercept form is fine. Of course, you could figure out the y-intercept, who looks very much like the tangent point, but can't possibly be the tangent point. Okay, so let's draw a copy of this picture for ourselves and see what we can see. I'll draw a big one first, and then we might zoom in where we need to. So radius 1 at the origin, and then a bigger one further down the line. And we'll get a nice tangent line. Point of tangency there, point of tangency there. Some x-intercept over here. Now, I'm really drawn to the x-intercept, so I might say it's something like, I don't want to use x because I might need equations for these lines, because knowing their origin, knowing their centers and their radii, we could figure out equations for each of these circles. I wonder if there's a formula for, given the equations, the, x minus h squareds plus y minus k squareds equals r squareds, to actually get the equations of the tangent lines. Because, of course, there are two tangent lines. There's another one heading down this direction, but we are specifically taking the top one, which is what they say. I don't know. Let's call this... No, n makes me think it's an integer, so let's say k. So k0 is the x-intercept. Okay, so what can we do? Well, they tell me points of tangency, so immediately I want to connect up my radii to my points of tangency. So 8 and 1 here, and we get nice little right angles. And these two triangles, let's say the small red one here, and then the bigger one, are going to be similar. So we might say, let K be the intercept here, and L and M be the points of tangency. In fact, let's write some of this down. So let K at K0 be the x-intercept, L, M tangent points, two circles with radius 1 and 8 respectively. Okay, so this has got to be the origin. Let's say P. So I'll let OP be centers again respectively. So 1 and 8. So OLK is similar to triangle PMK. That's nice because we know the ratio of their sides. Because PM over OL is 8 over 1, which is just 8. So what does that tell me? Well, that tells me PK over OK is 8, but OK is just the absolute value of K. I'm gonna make K is clearly negative. So I'm going to say negative K here. That way the little k that I use is positive. I think it'll just make things a little nicer and neater. So 0 minus negative k, and then we've got 25 minus negative k. So 25 plus k over k has got to be equal to 8. So 25 plus k is equal to 8k. 25 is equal to 7k, and immediately, seeing right angles, 25 and 7, I think of a Pythagorean triple, the 7, 24, 25 triangle. I bet there's a bunch of those lying hidden in here. Okay, so I'm even willing to bet that maybe OLK and OMK are have sides in the ratio of 7 to 24 to 25. It would remain for me to prove that, but that's right angles, 25 and a 7. I'm immediately thinking there's a 24 hidden in here. Okay, that's the experience you get by being comfortable with Pythagorean triples, and so I'm passing that on to you. Okay, so Pythagorean triple 20. So this immediately tells me that k is going to be 25 over 7. So the x-intercept k is at negative 25 over 7, 0. Great. We've got an intercept, and so all we would really need is a slope. Slope and a y-intercept, slope and an x-intercept. Slope and really any point will get you an equation for the line. So, okay, well, how are we going to do this? I'll draw a copy of my picture again. I'll do it a little faster. Okay. Let's make the other circle a little bit bigger. Get that tangency point going quite nicely. Okay. So, now, both of these are right angled to our line. So what do we call it? K, L, M, and this was O and P. So OL is perpendicular to KL, and PM is perpendicular to KM. So OL is parallel to PM. And yes, I'll use purple. I don't use purple very often. I can make a nice little rectangle here. So maybe call this point N. Let N be on PM so that ON is parallel to KM. So what will we have here? We'll also get right angles and right angles. So OLMN is a rectangle. That tells me MN is length 1, PN is 7, and then we've got ourselves, we'll use pink, a 25, because it's origin to P, 7, and therefore 24 for our ON. So I think we're getting close to a slope here. So, by Pythagoras, in triangle PON or NOP or something like that, ON has length 24, and if I were to drop a right angle point here, Q. Let NQ, let's say let Q be on OP, so NQ is perpendicular to OP. Then NQO is similar to, because they've got the same angle and they've both got right angles, it's similar to PNO. So NQ over OQ has the same ratio as PN over ON, and that's 25 over 7? No, it's 7 over 24. Yeah, the non-hypotenuse sides. Okay, so 7 over 24, well, that's exactly the rise and run of ON. So slope, rise over run. So that's NQ over ON is 7 over 24. And since KM is parallel to ON, KM, the line that we want, has slope 7 over 24. So using x-intercept form, which I'll remind you, if you're not familiar with it, is y equals mx minus a in brackets. This is similar to y equals mx plus b, except that uses the y-intercept. We get the tangent line has equation y equals 7/24 x minus k, but k was negative 25 over 7, so it'll be plus 25 over 7. Okay. So there's our formula. If you wanted to expand it out to y equals mx plus b form, you get 7 over 24x plus 25 over 24. Okay. So that means, just if I zoom in right at the x-axis, my line is tangent, and then, yeah, it intercepts just a little bit above the circle, which should make sense because the point of tangency should be over here. Okay, yeah, I agree with that. If you wanted to, one thing you could do, I'm not saying you should, because I would say the logic we've got here works perfectly fine for itself, but I would check, make sure this line is tangent to your two lines, and you could check this in a number of ways. You could check both circles, check the line is tangent to both circles, by asking, well, the first circle is x squared plus y squared equals 1, and my equation is y equals 7/24 x plus 25 over 24. If I plug that in here, do I get just one solution for x? Okay. This could also be another approach to figuring out something like the y-intercept. But, yeah, we get x squared plus 7/24 x plus 25 over 24 squared is equal to 1. I'm going to multiply both sides by 24 squared, so we'll get 576 x squared plus 49x squared plus 50 times 7, so 350x plus 625 is equal to 576. Oops, no bracket there. Okie dokie, so that should be 625 x squared plus 350x, and then subtract 56, 576 should be a 49. And so that'll be 25x plus 7 squared is equal to 0. And that does have exactly one root. Nifty. And you can do the same thing with the other one. I'm not going to because I'm confident in my work, but the other line has equation x minus 25 squared plus y squared equals 64, and I imagine a similar result will take place. But again, we're well past having answered the question. This is just a way you can check. Not so much for the people who are going to go on and do 9 and 10, but if you reach 8 and you take a look at 9 and 10 and say, I have no idea what's going on, and there's only so much time, check your computations, especially any of the questions that you were a little nervous on or that you felt rushed on. Okay, if you ultimately decide, I'm not getting this question, I don't have enough time, don't just hand in your paper or anything like that. Use the full time. Check everything you can. And this is one way to check that, yeah, this line really is tangent to that circle at the origin. And I trust, based on the niceness of my computations, it will be tangent to the other one. But if I had time, I would check. Okay? So, that was question 8. Up next will be question number 9. I will see you there. Until then, take care.